Alright, we're gotomath.com and we're solving limits numerically. And, ooh, there's 4 of them in this section. I'm trying to get 3 to pop up. There it is. Alright, we're evaluating the limit numerically. Here's the limit. The limit is x approaches 3 of x squared minus 9 over 6x minus 18. Let's move over to the whiteboard, and there it is. And we'll rewrite that limit as x approaches 3 of x squared minus 9, I believe it was, over 6x minus 18. Now we can say, well, we could start with this. So if we were given the limit as x approaches 3 of f of x, now this is the same, alright, is this asking this right here, same thing. This has just been defined somewhere else on the page, okay? Need to get that out of the way. Now the first thing I'm going to do here is I'm going to, now normally this isn't the procedure for solving limits numerically, but we're just doing this for a little extra here. If I factor the numerator, we end up with x minus 3 times x plus 3. We got a different squares. And I'm going to factor out a 6 out of the denominator here. And so we're left with x minus 3. Right? Now we got some like terms that we can actually cancel some things out. We can actually get rid of those two guys right there. And then we're left with f of x is equal to, we got this 6 down here in the bottom. And I guess I'm going to write it like this. Plus 3 over 6, which actually that could be reduced down to x over 6 plus a half. Look like a Hilton X there. X over 6 plus a half. Anyway, the reason I'm actually doing this is kind of getting you ready for the next section and kind of getting an idea of what this graph looks like. Alright, if I took 3, we did this with things called direct substitution, and well, if we took 3, if we evaluated f of 3, we end up with 18 minus 18. We end up with 0 on the bottom and 0 on the top. 3 squared minus 9 is 0, and so that's not good. So we don't know. We're gonna say this is what the graph looks like, whether it is or not. It's not to scale, but anyway, here's the missing point right here. So if you took 3, of course you plugged it in to this up here, you get 0, 0. That tells us there's a point missing in the graph, and we'll say that the y value of this missing point we'll say is L. Now something I left out here, these two functions here need to be the same function, okay? And what we need to do here is in the domain we'll state it that of course the domain of this guy is all real numbers, but we need to state this so they're both equal, that that x cannot equal 3. Alright, we're not allowed to use 3. We're not allowed to use 3 here. Now we can say that these are actually both equal, even though they look radically different. Alright, now the idea of course is to know where is this missing point. Well, we can't do it by just this function, by plugging a number in and getting it out. Alright, we had a pause there, and I'm not sure where I left off at, but where am I don't know. Anyway, so numerically, got a lot going on. We want to come in from the left hand side here at 3, and we're going to do it like this. So we're going to start at, let's say, 2.9, something close. right? And we take 2.9 and we just plug it in up here. 2.9 squared minus 9. Of course, I'm going to let you get the calculator out, figure out what that is. All right, and then do it again. So, you know, if you've watched some of these uh, videos I've done on the previous problems, you know, I mean, it should be clicking by now, surely. It's 2.99. Of course, you got to multiply it by 6 minus 18. All right. Anyway, that's coming in from the left-hand side. Of course, we'd want to come in from the right-hand side, and that's going to be, we'll start with 3.1 and plug that in. Squared minus 9 over 6 times 3.1, then minus 18, right? And then, you know, continue to do that, 3.01, 3.001. And as you can see here, all right, and really the most important part about this is that we look at coming in from the left-hand side. We'll let L be left. Coming in from the left-hand side, it's equal to some, you know, it's approaching some number. And then coming in from the right-hand side, I should put my arrow actually in this direction. These two numbers need to be the same, okay? If these are totally different, coming in from the left, coming in from the right, are two different, converging to two different numbers, then this limit doesn't exist. And I'm sure I'll be working some of those kind of problems out. But let's kind of move over here real quick. I'm going to click the help button here. And as you can see here, we approach 3 from the left. Right, so we get to 0.98, 0.99, 0.999. So you can tell this thing is converging towards 1. And then we do it again. And as you can see here, that it looks like it's converging towards 1. And is it really converging towards 1? What's going on here? Sorry, I need to look at something here real quick. 3. Yeah, 3 over 6 is a half. Half plus half is 1. Yeah, I don't know. I was thinking of something else. But anyway, answer. Gotta watch that every once in a while. Something sneaks up on me. Alright, I'll see you there. Go to math.com.